Hello everyone, welcome to another video. This is part 17 of my Gateway API for Kubernetes series. This is going to be probably the last video of the series, and today I thought I'm going to show you a little bit different because I've shown you everything from the Gateway API I want to show you already. So therefore I'm going to show you how Ingress works with the Cert-Manager, so you can have a comparison of the Gateway API to the Ingress. So the plan for today is I'm going to use Nginx Ingress, and we're also going to install the Cert-Manager. This means we're going to have a demo application with HTTPS. So it's going to be the same setup as we had with the Gateway API. And then obviously I'm going to show you the demo. Before you bring your pitchforks to the comments, I know Nginx Ingress is end of life in March 2026, but the point of the video today is just to give you an overview or just a comparison between Gateway API and Ingress. Nginx Ingress is the one I've used the last couple of years, so I know best how it works, and for the sake of the demo, it doesn't matter which Ingress you use. If you want to use Ingress yourself, just keep in mind that this one is end of life in around 1 month after this video publishes, and you should look for another solution like Traffic. The reason why I used Ingress in the past and why people still use it is it's kind of easier to set up. I have this easier in quotation marks because to me Ingress was always a bit of magic. Like you set it up and it works and you don't really know how it works or why it works. The same if it doesn't work, it was so complicated for me to figure out why it didn't work, especially in the beginning. Now I've debugged it and troubleshot it a lot, so I think I know my way around, but the beginning was quite hard for me. On the other side, with the Gateway API, it was always clear to me what was happening because I had all the resources which I deployed myself. Like I had the gateway class, the HTTP route, and therefore it was easier for me to learn and to use it. Obviously, I have more experience now, so this also contributes to the easier setup and easier learning. But if you only want to deploy one solution and don't care about the details, then Ingress is probably the easier one. As I just said, when I started learning how it works, it felt a lot like magic because we're going to see with the Ingress controller, then we're deploying the Cert-Manager and our application which has an Ingress YAML file. That's it. The Ingress takes care of everything else. So it felt a lot like magic that's going on because suddenly the routing worked, then the TLS setup worked, and everything out of the box. But again, as I said, if it doesn't work, it was a pain to figure out why it didn't work. I think that's enough introduction. Let's switch over to the terminal and let's deploy our AKS cluster and then use Ingress Nginx. Alright, here in the terminal, let's define a couple of variables. So these are the variables for our AKS cluster, the name, the location, and the resource group. You can use whatever Kubernetes cluster you want, but since I'm an Azure guy, I always use AKS. Then we define a couple more variables for the namespace where we're going to deploy our Ingress, the namespace for our Cert-Manager, and also the namespace for our demo application. That's all the variables I want to define. Next up, we're going to create a new resource group. Again, if you don't use AKS, you don't have to do this. You can just reuse the cluster you already have. But for now, I'm going to create a new AKS cluster. And as always, you will find all the demo code and examples in the description down below. So you can just download them from GitHub and follow along the demo. Deploying the AKS cluster will take around 5 minutes, so I'm going to stop the video here and I will be back once it's finished. The deployment is finished. Now I can download the credentials so we can access the cluster. And with this, we can now start the deployment of our Ingress. So first, I'm going to add the Helm chart of the Nginx Ingress. As you can see, I've already had this before. Then I always like to do an update just in case there's a new version. Now we can deploy it. Let me paste the Helm chart here. It's a basic Helm install. I provide the namespace. I create a new namespace. Then I have here 2 replicas. Usually I use 3, but for the demo 2 are enough. This means if one of the pods fails, I still have my Ingress running in another pod. Lastly, I have the path for the health probe for the Azure Load Balancer, and that's health set. Let's apply this. It should only take a couple seconds, and this will create the load balancer service and the 2 pods. Since I'm using AKS, the load balancer service will also get a public IP address assigned, and I can use this public IP address to access the Ingress and therefore access my applications. So let's query the public IP address. So all I do is I get the service I just deployed and I write the IP address into the variable. So if you now print this variable, we should see the IP. Here we have the IP. So I'm going to copy this one and let's move over to the Azure portal and update the DNS there. Here in the Azure portal, you can see I've already prepared the Ingress and I tested it before with a different IP address. So now we're just going to change this IP address. If you don't have anything set up, all you have to do is create an A record. This means you provide the IP address, the name or URL you want to use. Then we can apply these changes or create the record set. So here we can see we have now our new IP address. This means the URL ingress.programmingwithwolfgang.com points now to the Ingress. This means I can now create the Cert-Manager, then deploy my demo application and open or reach this demo application with this URL. So now let's switch back to the terminal and let's continue with deploying the Cert-Manager. Back in the terminal, let's clean this up. Then we add the Helm chart of the Cert-Manager. This is exactly the same Cert-Manager we have been using for the Gateway API. So I again had this Helm chart already added. Then we're going to do an update just in case you haven't followed the first part and just to be sure everything is up to date. Next up, we're going to deploy the Cert-Manager. So here you can see it's as simple as it could be. We provide the namespace, we create the namespace, and then we also deploy the custom resource definitions, and therefore the certificate request, like everything the Cert-Manager needs. If you remember, for the Gateway API, we also had one additional parameter where we said we are using the Gateway API, but since Cert-Manager is quite old, like the Ingress, we don't need this, and it selects the Ingress by default. Now this should take, again, only a couple seconds. It will create the namespace and then deploy Cert-Manager into this namespace. Once this is done, we can also deploy our ClusterIssuer. So here you can see the deployment is finished. Let's clean this up. And as I said, we will now deploy the ClusterIssuer. The ClusterIssuer defines from where we want to get our certificates. So you can see we have the type ClusterIssuer. Then down here I have 2 URLs. So the first one that's commented out for now is the production server or URL to Let's Encrypt. And the second one we are using for now is the staging server to Let's Encrypt. The reason why I chose this setup is you get, I think, 5 registrations per week on the production server, and I think an unlimited or close to unlimited amount for the staging server. This means if you start testing, you should always use the staging server because 5 registrations is not much and you can run out easily. I'll also show you how to switch this, but for now that's good enough. Then we provide a email. So usually you get notifications, for example, if one of your certificates is about to expire and it will be renewed automatically. And on the bottom down here, we have our solver. And here we only have to define or tell the ClusterIssuer that we're using Ingress and our Ingress class is Nginx. If you remember, for the Gateway API, we had to define that we're using the gateway API, in what namespace we have deployed it, and the name of the gateway. I haven't mentioned the Ingress class before, but this is almost the same as the gateway class. So it tells our Ingress objects what Ingress controller it should use to process the request. In this case, it's Nginx. So let's save this and apply our ClusterIssuer. Also, what's important is we don't need a namespace for the ClusterIssuer. It's a cluster object, so it doesn't live in a singular namespace. All right, so this is the entire setup we need. Now I'm going to create a new demo application. I'm using a Helm chart and we deploy this Helm chart. So first up, let's create a new namespace. Then I've already created a new Helm chart, but if you want to start out completely fresh, you would do a Helm create and provide a name. But since I already did this and I like to have my Helm charts in a charts folder, let's switch into this folder. And then let's open Visual Studio Code so we can take a look at the Helm chart. So here we have, let me make this larger. Here we have the Helm chart. Here inside this templates folder, we have all the resources it creates. So for example, we can see here the Ingress, our service, and the deployment. So these are the main components we're using today. But if you use the gateway API, you can also see here we have the HTTP route. The probably most important file of Helm charts are this values YAML file, and there you can configure everything, like all the variables that will be put into the Helm chart during the deployment. I stripped down this values YAML file to only the necessary entries. So if you create a new Helm chart, it will look a bit different, but here you can see everything that's necessary for the deployment. So for the image, I'm going to use traffic who am I. It's my favorite test image because it gives us some information. It's small and easy to use. Then for the service, we're using cluster IP and port 80. That's the same setup as with the gateway API, because in this case, we want to connect to our application through the Ingress. Therefore, we don't have to be, it doesn't have to be available over the internet. Therefore, cluster IP. Down here with the Ingress section. So first up, we enable it. This means inside the ingress.yaml file, we have an if condition. And if you enable it, it will deploy it. If we use gateway API, for example, we have this enabled set to false, so it won't even be deployed. Then we provide our Ingress class name. That's the same as before, Nginx. Then this annotation is important to have HTTPS working. So we tell the name of the cluster issuer. So in this case, I had my cluster issuer named Let's Encrypt. Next up, we provide the URL. That's the one we configured in our DNS. Then you can have a couple routing rules. That's the same as we have in our HTTP route in the gateway API. But for now, I just keep it as simple as possible and just route everything to my application. And lastly, we have the TLS secret. This is the secret that will be used to store the certificate. So we have to provide a name, and then we have to provide again the URL. That's it. That's everything we have to set up for our Ingress. If we scroll a bit further down, we just have all the other files we have to configure but not use. For example, liveness probe is just the root folder, the same as the readiness one. And autoscaling is the horizontal pod autoscaler and the HTTP route. They're both set to false. This means they are not being used, therefore also not being deployed. So now we can deploy our Helm chart. And to do this, we use Helm install. Then we provide the name of the Helm chart. Then a name for the deployment. In this case, I chose the same one. And in what namespace we want to deploy. So this is the new namespace of our demo application. Then what's nice, it already tells us the URL because it read it from the Ingress configuration. But now we have to wait a couple seconds. Usually it takes around 30 seconds for the Cert-Manager to set up the TLS certificate and therefore have the HTTPS connection. So if you click this link too quickly, you will get probably a warning that the connection is not secure. But while I was talking, the certificate should have been created, and we can also check this with a kubectl get certificate and then our namespace. So here you can see we have our name. Then the most important part is here, the ready set is set to true. This means everything worked. If it's false and you waited 1 or 2 minutes, then probably something is wrong in the configuration. And lastly, we have the secret. So this is where the information is stored. This command also shows another kind of downside of Ingress, because you have to use the namespace. So everything for our application is inside our namespace. With the Gateway API, we can have it in different namespaces. For example, I can have the namespace for the gateway, and inside this namespace, I can have the certificates. And therefore, I could set up that an infrastructure team takes care of everything, and the development teams only have the HTTP route and the application, the namespace. As I just said, the important part is here that the ready is set to true, but in case it is set to false, we can take a look at what the problem is. And the way to do this is just a normal kubectl describe, kubectl describe certificate. Then we provide the name. So this name is the same one as here. And again, we provide our namespace. If we execute this, we can see here everything worked as expected. So the certificate has been successfully issued. But if something does not work, then you would see here an error message, or at least a hint why it didn't work. So it could be maybe of a typo in your URL, and it will tell you what the issue is. Then we can also take a look at the secret. So here you can see our Ingress TLS secret. It was created around 2 minutes ago. So this was automatically created by the Cert-Manager. And again, if something is not working as expected, another resource you can use is the certificate request. So this is the request that is sent for the certificate. And here you can see it is approved true and ready also true. So everything worked as expected, but this can be sometimes pending. Again, if you have a wrong URL configured or anything else is not configured correctly, it might be either denied or usually pending. If you want to check what happened, we can do again a kubectl describe for the certificate request. We copy the name of the request and then we take a look. Here you can see the certificate has been fetched. We have the order for this certificate and we have the certificate request. So everything is great, no error message, nothing. But if we have an error, we should see it there. Now that's everything we need for our test application. So now we can open the browser or use curl and access our application. So here in the browser, we can see I entered my URL. That's ingress.programmingwithwolfgang.com, what I've configured before. But here we can see we get a warning. So now if we just advance and we proceed to our Ingress, we can still see we can reach our application, but we have this warning and it tells us it's not secure. So if you click on this and we can take a look at the certificate details, then we can see we have here a staging Let's Encrypt certificate. This means we got our certificate and it was applied correctly, but this shows the one downside of the staging certificate. It's not a fully production ready certificate, so you'll get this warning. But what's important is that we tested the entire process and we were able to get the certificate and also reach our application with our URL. This means we are now ready to switch to the production Let's Encrypt server, and then we should get a production ready certificate. Therefore, let's switch back to the terminal and change our ClusterIssuer configuration. Back in the terminal, I paste again the ClusterIssuer, and what we can see is the only change is here in the ACME. So the server, I'm using now the production server of Let's Encrypt, and I commented out the staging server. Let's save this in the variable and apply the variable. And then what I also always do is I delete the old certificates and the old secrets, because then the Cert-Manager sees they're not around anymore and creates new ones. In general, in my experience, if something goes wrong with HTTPS, TLS certificates, it's always a good idea to delete the certificates, the requests, what you have, and then let Cert-Manager create a new one. So first we're going to delete the secret. That's the one we had before. And then we're also going to delete the certificate request. So that's also the one we have seen before. Now the Cert-Manager is going to see that I want an HTTPS connection, but I don't have a secret or a certificate request for the TLS certificate. Therefore, it will request one from Let's Encrypt, in this case from the production server, and this will give me the production certificate. So if we now check our secret, if we have waited long enough, we should see that we already have one. There you can see we have our secret, and it was created 16 seconds ago. That's good. Now let's also check our certificate request, and there you can also see ready is true, approved is true, and it was 50 seconds ago. So the only thing that changed is now we have the name plus the 2 at the end, because it was the second request we made. Now I can switch over to the browser again and check if we have a valid TLS certificate. So back in the browser, now let's refresh our page. Here we can see something browser specific. So the HTTPS went away. This means we have a HTTPS connection now, but it still says not secure. This is just a browser, maybe caching or UI thing. So what we can do now is open a new browser window, and then we should see it's working as expected. Here, as you can see, I opened a new browser window. The warning has been gone, and if I click now on the certificate, it says here the connection is secure. If I click on this, then I can see I have a valid certificate, and on the certificate I can also see now it's from Let's Encrypt, and I didn't get any error message, any warning, so it's a full-blown certificate, and it's valid for 3 months at the moment. This is everything I wanted to show you today. So like with the Gateway API, using the Ingress and the Cert-Manager to have an HTTPS connection is quite simple. There are also a couple of resources in the background, like the certificate and certificate request you have to be aware of, especially if something goes wrong. But overall, I think it doesn't matter if you use the Gateway API or the Ingress if you want to learn about the Cert-Manager. Both are quite simple and both are a great learning tool. If you're already using Ingress, I don't really see a reason why you would update to the Gateway API, except if you're using Nginx Ingress and it's end of life almost in around 1 month after this video was published. Therefore, I would probably update to the Gateway API. And if I start out completely fresh, I would go with the Gateway API. On one side, for me, it was always easier to understand how it works. I can use different namespaces. This means maybe now or in the future I can have a separation of concern between different teams. And to be honest, it's also the new shiny thing, and I like shiny things, therefore I would select it. Overall, if you use Ingress, you're still not going wrong as long as it's not end of life, and therefore you should pick whatever is the best for you. This is probably the last video of the series. So next week I'm going to do a conclusion and recap of all the 17 parts we have done. This means from installing the Gateway API, comparison, Ingress, and gateway API like the first video or this one, and some of the features. I hope this series was useful to you and also this video. If you have any questions or comments, let me know down below. I would appreciate if you like the video, if you share it, and I hope to see you next week with the conclusion of the series.